Hello everyone and welcome to today's Mondac webinar in association with Dennemeyer and an expert panel who will be discussing the cutting edge advancements in generative AI and their transformative impact on intellectual property management with a special focus on research and development. My name is Dan Sampaio and I'm joined by a brilliant panel to take us through today's discussion. Dr. Michael Natterer co-founded Optimind Technologies and developed its core technology. His expertise includes business development, product innovation, AI, machine learning, and predictive patent analytics. Following Optimind's acquisition by the Dennemeyer Group in 2018, he continues to lead the company while also building the Dennemeyer Innovation and Corporate Development units. He is a frequent speaker on AI and regularly moderates panels on emerging technologies. Michael has a strong background in technology, business and entrepreneurship, holding a PhD from the Max Planck Institute Munich and LMU Munich, specializing in large-scale machine learning with patent data. Eckhard Siegmann studied electrical engineering at RWTH Aachen University and has more than 25 years of experience in industrial measurement and control technology and machine vision. He initially worked in a startup, which was later taken over by MAG Germany, where he developed online machine vision systems for the quality assurance of plastic pelletizing systems. As head of AI, he is helping to shape the digital transformation of the machine and plant manufacturer. More than 8 years ago, when AI was still an exotic topic, he gave presentations at the Aachen Machine Learning Meetup. One of his first talks ended with the words, "AI is here to stay. There will be no more AI winters." And completing today's panel is Robert Schermeyer. Robert is a seasoned professional who launched his digital journey on a second-hand Z80 computer. He cultivated his expertise in business administration through rigorous studies in both Germany and the USA. Robert honed his strategic acumen working with top-tier international consulting firms in the tech industry. In 2004, he took the entrepreneurial leap, establishing his own strategy consultancy firm. A decade later, in 2014, he began steering his IT enterprise, Value Miner, toward becoming a pioneer in the AI domain, positioning it on the global stage. Now, before I hand over to the panel to begin today's webinar, a quick housekeeping item. You are able to submit questions to our panel by typing them into the questions pane of the toolbar on the right-hand side of your page, and we'll endeavour to answer as many of those questions as possible. It's now my pleasure to hand you over to Michael, Eckhard and Robert to begin. Thank you.
Perfect. Dan, big thanks first of all for this very kind introduction, and of course a very warm welcome to all the people here in the audience. Big thanks for joining us for the next 60 minutes, me and my colleagues Eckhard and Robert. So before, however, we go into the session, I also quickly give a little bit thanks and credit to the Mondac team for organizing and hosting this session, as well as to the Dennemeyer events and marketing team, and of course also to the marketing team of Value Miner. Great to have you in the background. Without you, this session also would not have been possible. So now the next 60 minutes, what we're going to do. The agenda, roughly, we're going to have 4 different sections. The first one is we do a little live poll with you to learn more about you people in the audience. Please don't run away. It's the questions are simple. It's not a quiz, so nothing that should be a problem. We simply want to get a little bit of feeling for our audience today. And then we're going to go into the presentation part, where I'm going to talk a little bit about the status quo of AI, especially also a little bit about the limitations on the reasoning part. Eckhard will walk you then over RAGs, agents, multimodal models, all those trending technologies these days. And Robert is here for the cream on the cake, because he combines then the RAGs with the knowledge graphs, which is really at the cutting edge of the technology. After the presentation session, we're going to have a quick panel session where I'm going to take the moderation role, and I will have a couple of questions, especially about the applications in R&D and IP, to Eckhard and to Robert. And then, of course, we also going to give you the voice, where we have then, of course, also questions from your side that we are going to answer. For all the questions that we are not able to answer, we'll get back at least in a written mode. But now let's get it started. Let's have a quick look at the poll. So this is already fantastic because this changed so much over the last couple of months. Yeah, when we did these polls in earlier workshops, then the distribution looked exactly the other way around. And obviously now things really changed very quickly.
Nice.
So good. I think that's great. I think the pattern is also a bit stable. I think we can then directly move to the next one. Perfect. Looks almost like a normal distribution. So we have a clear mode, and then of course a little bit of everything. That's also very interesting. And Robert, I think this also speaks very much to the audience. I think that the audience has a very good feeling about what AI is able to do in these days.
Absolutely. I find this highly interesting because, as you said, it just changed over the last month. So that's brilliant.
Good. And then our last one.
Here you can select multiple options.
Yeah, also this one, I think it's a really a great confirmation actually of the core function of current AI tools creating and summarizing content. Yes, I think this really hits the nail. Interesting. Gen AI acts as a teacher? None. Okay, also interesting. And Robert, I think you need to work a little bit on analyzing data and programming. I think you can say a few words more when you come to the knowledge graph. Okay, fantastic. So first of all, big thanks to the audience for joining us a little bit for that poll. I think we got a very good impression over how you think about AI, what you're going to do with AI, and I think we can definitely adapt to it. So let's get it started with the presentations. So the first message that I really want to bring through is that independent of any kind of limitations or whatever, the key message from my side is that it's fantastic to have Gen AI at work because it helps us on so many areas, and it's really something that's super useful and also valuable. And just to start with a couple of facts, and I think the facts then also speak for themselves. The left ones are quite general, so it's not so easy to get accurate statistics on that. So I took the ones that OpenAI presented themselves recently, where they announced that they have more than 200 million weekly active ChatGPT users, and such numbers. Yeah, there's nothing more to say. People really find it valuable. At least for certain use cases. And then also when you look at the adoption rate at the Fortune 500 companies, 92%. Okay, it's also difficult to say how they're going to use it. Are they using it as a tool or via a third-party platform, via an API, or have they just played around with? This is hard to say. But anyways, in such a quick and short period of time, it's great to have such kind of impressive stats. Then a little bit out of the IP domain, some statistics we did end of the year, so it's already a couple of months ago, we did a little survey on our own, and there we also came up with a result that 90% of the patent attorneys have tried LLMs. Some of them also integrated it in their daily work, and also when we look at the vendor side. Yeah, so it was, I remember in a panel session 4 years ago, there was the clear opinion that patent drafting is most likely the last thing that AI can touch. Why? Because of course it's really the intellectual skills of the patent attorney. And then Gen AI came around, and out of the sudden we have more than 30 companies offering tools and software to help with patent drafting. So we see there a tremendous speed in the market, and I think really things have changed, and there's really so much value. But so much about the facts. We also need to have a couple of stories. Stories are normally always a little bit better to transport a message. Here I have one from chemical research, from the chemical industry. This one is called the co-scientist, and the co-scientist, it's an agentic model, and Eckhart, we will say anyways a bit more about agentic systems later, but just in a nutshell, an agentic system, it's always a combination of LLMs and also other tools. Normally there is a certain supervisor, and the supervisor has access to so-called worker agents, and the worker agents, they have again access to so-called tools. Tools means you can access the internet or the wallet or the credit card or any kind of other tool, database, whatever it is. And normally then they follow a certain workflow in order to solve a certain set of problems. This one is now from the chemical industry, and it should help synthesizing complex chemical molecules. For example, the synthesis of aspirin or ibuprofen. This is roughly the problem statement. And then the agent here, the co-scientist, should automatically find solutions, plan, and also organize, and finally also test whether the synthesis is successful. That means there is also a physical component. That means the test setup will be sent to a cloud laboratory. It will be tested. Results then finally will be sent back. And as you can see here, the supervisor, this is a little bit the planner. The planner has access to other tools, modules, or those worker agents, for example, a web searcher. The web searcher looks in the internet, but also in certain chemical databases for different ways on how you can synthesize molecules like aspirin. And then he gets different solutions back. He starts evaluating them, ranking them, and then he also has a certain degree access to code, to Python code. So that means he can also create his own programs that he needs in order to measure certain things. And he also needs the code in order to send later on a certain script to a cloud laboratory where the testing is happening. But for this, you also need to have a documentation. Because typically when you interact with a physical machine, you need to have access to how does the API work, how are the variables called, and then you need to adapt your script or your code that you have been produced before. And this is where the planner gets the additional information, can fine-tune, correct the mistakes. For example, if the heating device is not called heating device, if it's called heater 1 or heater 2 or heater standard, then this is what it learns from the documentation. And finally, the experiment starts, and the whole script will be then sent to the cloud laboratory. Results will get back. The results will then be summarized and sent back to the person interacting with the co-scientist. And I think that's a pretty fantastic proof of concept. It's a proof of concept also, to be honest, but it shows us what is possible, and there are really not too many limits there. And it's just one of many examples. I recently came across to quite a lot of examples from the chemical industry. Then maybe another one, going into a complete different direction here. Here we go to text to image models. And I think you all have used DALL-E. I use DALL-E regularly for my presentations when I want to create a nice image that I want to have in the background. And I tried DALL-E, and Robert, now you need to forgive me. I prompted DALL-E and I said, I want to have a picture of Robert standing in the middle of the Madison Square Garden. And yeah, I got the response, it doesn't know Robert Schiermeier. I'm very sorry about that. But now comes the good thing. I also did the same with Michael Jordan. Please give me a picture of Michael Jordan in the Madison Square Garden. And he did great games there. But what happened, I also didn't get a result, not because the machine didn't know Michael Jordan, but it's against the policy. Yeah, and that's a little bit the problem with the tools. You cannot ask for local content. Yeah, you cannot ask for certain pictures maybe about yourself. And that's something that a small startup in Luxembourg can do, and that's LetzAI. And here you see a picture of, he's the founder of this company. So he uploaded 5 to 10 pictures of himself. And then he used stable diffusion model in order to create a picture of himself in the middle of a medieval battleground with cannons in the outfit of a knight. Yeah, this was also roughly the prompt. And this in a ultra realistic image. And this is what you can see over here. And this is now a little bit ego, of course, because if you want to position yourself somewhere, that's great. But think now about products. You can put in your products there. And that means in the end, if you want to have your product, your shoes somewhere, I don't know, at Copacabana beach, and you want to position your shoes there, then you don't need to fly your shoes there. You don't need to have a model. You don't need a photographer there. The only thing what you need an application like this, and they already deliver very high quality results. And I think that's also fantastic to see how these technologies can really disrupt complete industries. But before we're gonna talk too much positive about those things, there are also a couple of, let's say, limitations. The first 3 limitations, classic ones: knowledge base not up to date, local context, domain knowledge, hallucinations. Some of them, Eckhart and Robert will say a few more words because RAGs, knowledge bases, knowledge graphs can tackle them, at least to some extent. I'm gonna focus now a little bit more on the reasoning part. And what you can see here on the left side, this is, and you know it all, this is how an LLM works. That means you give it a question, or in computer language, you give it a couple of strings. The strings goes into the black box with all the encoders, decoders, positional embeddings, attention mechanisms. But in the end, it produces the most likely next word given the input string. And then it takes the input string plus the predicted word, and then it predicts the next word on it. And this is in the end what it does. That means it consumes speech and it produces speech or text. Now, what can we learn from language research? And I came just 2 weeks ago, a super article from Fedorenko scientists in the area of linguistic and brain research at Harvard, MIT, and Berkeley. And their title, and it's one of the very few articles where you see already in the title, what is the message? Language is primarily a tool for communication rather than thought. And now if you look at the fMRI scans there, on the left-hand side, you see this is the brain activity that you have when you speak, read, or when you write things down. So that means language comprehension, language production. Then those areas get activated. However, when you do other things, planning, reasoning, problem solving, mathematics, or with your computer code, then it's different areas. And again, different areas when you do social reasoning, mentalizing, and those kind of things. So the clear result from this research, and they really reviewed the last 20 years of empirical and theoretical research, is that language is for communication. It's not for thinking. And now let's turn a little bit the coin around. Why do we expect that a language model like GPT-4 thinks like a human? Yeah, I think this is maybe a little bit too much. And this is also a little bit the hypothesis I have. But hypotheses are only quite dry or not useful if you can test them. And the testing did some other guys, another research paper, and they used the ARC, the abstract reasoning, and reasoning corpus, where exactly reasoning skills are tested. That means the machine, typically, and the human, they get a set of examples. Yeah, here you see, this is one picture, and this picture leads to that picture. Here is again another example. And what you see on those examples, some objects will stay, some objects will disappear. And if you now carefully look at those examples, then you see, independent of the color, the objectives of the same size, they will stay. Yeah, in this case here, the squares stay. Here the crosses, it's the same, and also those ones here. So a very simple example. And then, of course, on the test side, people have to do it, and also the machines have to do it. Now the question, how did machines and the humans perform? Of course, for humans, very easy. 90% get it right, even more complicated ones. But the machine, GPT-4 in this case, really struggles with it. So accuracy rates lower than 30% are a little bit the case here. I've also seen higher rates, but then you have to challenge a little bit the test setup. This is really hard for a machine like GPT-4. But now a little bit the good part about machines. If you train a machine, and some other researchers did exactly this, they took an MLC transformer specializing on skill acquisition tasks, then it is very clearly possible to see that machines can also go to the same level. But we cannot simply expect this from a simple language model. So this would be simply a little bit too much. And therefore, those tools are fantastic, but we also need to be careful when it comes to reasoning. And by this, I would like to hand over to Eckhart.
Michael, many thanks from your side. So my take is on your points. ChatGPT can understand. The training data of a pure large language model is very unsuited for this reasoning task, and we have not yet the hand-eye coordination in the training data. So the AI wants sometimes draw something and ask it to generate an electric circuit. And it came up with some ASCII art, so dashes and then symbols for the resistor and capacitor. And this model was already there. It wanted to express itself by drawing something. But this is an unhobbling that has not really been done. So it is not to blame for the architecture, it's to blame for the training data, and that we do not yet have this hand-eye thing integrated, that the agentiveness the model is probably capable of has been part of the training set, and therefore we see here the fail. So I want to open your mind to the speed of development, and the speed of development is mind-boggling, and we see very, very fast development. And just to have an analogy, we just start with a snail, and 3 meters per second, 100 times faster is a mouse, and then again 100 times faster is a bicycle with 30 kilometers per hour, and a bullet train with 300, and then 1,000 times faster within 1 hour, you're at the moon, 300,000 kilometers per hour. And 3,600 times faster, we are at the speed of light. So from the speed of a snail to the speed of light, we see here a development unfolding in AI. And from GPT-2 preschooler to elementary schooler to smart high schooler, it was a period of just merely 5 years. So within 5 years, the equivalent of what a child would have developed within 15 years. So we have a growth. Oh, this was one click too much. Sorry for that. We see a 10x per year AI development. This accounts for partly silicon. A lot in the development is not the pure silicon and denser transistors, but bringing memory and transistors where the compute is happening closer together. In our smartphones in 2026, we will see that the compute is not next to the memory, but the memory is on top. So the interposer will be gone, and from millimeters where the data has to travel, the distance goes down to micrometers. And who has not seen it, this situational awareness AI where this slide is taken from, is really mind-blowing. It's six months old, from Leopold Aschenbrenner, one of the German Wunderkinder in the US. At the age of 22, he left OpenAI, and he was allowed to speak. Ilya Sutskever will have to pay millions of fines would he speak out in that kind of manner. But the projection to the right is what Leopold Aschenbrenner just projected. So the additional silicon speed up combined with the algorithmic speed up, factor of 10 year on year. So this will lead within very short time to agents that do what exactly Michael showed in the very beginning, but at a much higher level of reasoning. So with GPT-5, we are going to expect a breakthrough regarding reasoning, as OpenAI has since 1 year an internal GPT-5. They never deployed it. I know from a friend of mine that it is there working since 1 year. And this AI has been used as a teacher. This model was so huge, there was no way to deploy it to the world. But this model has been used to generate training data for what we now as normal people will get deployed as GPT-5. There is a much smarter AI system in the background, and the silicon pathway is going forward and the algorithmic pathway is going forward, so no barriers for the next time. So AI models have problems with hallucination. You can try it out on Hugging Face. Very simple. Take a small model or use GPT for all that you can deploy on your smartphone or on your laptop computer. You download 7 billion parameter model onto your laptop computer, and within 2 minutes you can ask your large small language model or medium-sized language model. But to have it simple, we call even the smaller models large language models. Without any data leaving your laptop computer, you can ask your small model. And what you will find when you have a smaller model deployed is that you end up earlier in the hallucination range, where the safe ground of the knowledge is lost. Yeah, because the smaller model has not so much safe ground knowledge. So in the past, the models got larger and larger and larger, and more training data created larger models. So the area of hallucination was pushed so far that normal people have hardly a chance to bring it to hallucination. But if you ask it, what is in my own cellar, it is forced to hallucinate. Has no data. So AI is all about data. So, and organizations as our corporations, they have a lot of data, but there are tools to make it accessible and to patch the knowledge. And this is what's important thing. So we have a query. So for the simple case, what is in my cellar? Okay, maybe put it what we have in our warehouse. So, but we have in a vector store some information about this. How to retrieve it from the vector store? You have to transform our question has to be formulated in some numeric representation. We call this embedding vector. So with an embedding, we transcribe this question into a numeric transcription into this embedding vector, and then we query the vector store for similarity. Okay, so we have a bunch of documents that is quite similar to my query and related. And these documents we simply copy into the context of the large language model. And now we have patched the knowledge. And the prompt says very simply, answer based on context. So this looks like that. Answer based on the following. Then there are maybe four knowledge chunks from this is RAG, Retrieval-Augmented Generation. So the knowledge chunks are retrieved from the database, and then the task is use only information from this context and answer the following question. and then the user query is answered based on the result. So this is the architecture underneath it. So first, the question is converted to an embedding vector, then queried to the vector database, then some documents are retrieved, but we do not use full documents. As documents have many different topics. So what is best to have chunks, and to have good chunks, the best is that a large language model with special prompting selects where to apply the margins. So the old thing 1 year ago was just have 1000 tokens and 20% overlap and do some hard chunking. No, this is the old way. Forget about it. Let a large language model with an appropriate prompt process your large PDF files, and then have an abstract, and the large language model generates a nice heading for that abstract, and you have some reference to it, and everything goes to the context, and then the response is generated from good cooperative knowledge. And what's important, that the vector database, Robert will focus on that, is filled with data where you are allowed to access it. So when the boss is asking the question, the boss has access to more documents. So the Active Directory allows the person to access more data. So the vector database will come with a more insightful documents and knowledge chunks than if the question would have been posed by some lorry driver. So this is just language thing. But since 1 year we have multimodal large language models, LLMs, and there is one little trick. This embedding vector has been trained in a multimodal way, that an image and a text comes up with the same meaningful vector representation. So they can ask the question in image form, or you can ask in text form, and this similarity research will come up with documents or images that are similar. And if you ask maybe for some documentation in the manual, and there's some image in the manual that is closely related to your query, then this document, this image of the machine will be copied into the context, and then for the user, it's looking really nice, as in the response all of a sudden is a nice image of the machine and some explanation what to do about it. But the large language model did only merely copy the answer from the context above. So the job for the large language model is very easy. And this is a very, very important thing for you to remember. Whenever you work with large language models, make the job easy for it, and it will work reliable for you. So now we just go back in our mind. In 2 years' time, the large language models will speak 100 times faster. Can you speak 100 times faster? Forget about it. And reading as well, forget about it. So the machine has to speak with itself. So we just move the operator, the user, away, and now we do not have a prompt anymore, but we have a mandate. And the mandate includes the task and the resources, maybe API keys to some auxiliary interfaces where valuable information can be taken from. And then the agent is processing what the input is and generates the questions on its own to query the vector store, and querying not only the vector store, but in addition, further tools. So we have here now the agent has a long context. So this is an addition to here what this multi-language model does. Here we have the agent has a context of his own or her own or its own. Yeah, and this context, yeah, is now the work document, and now the agent is working like what Michael demonstrated in the very beginning. that it's doing chemical research, and all of a sudden the model sees, okay, I've been informed, I have tools, oh, I use the tools give me some feedback, oh, I have databases, I get feedback, I have access to the internet. Yeah, and then in the very end, and this is where Robert comes in, a very, very valuable thing is a graph database. In a RAG store, we have this proximity, and sometimes close things are not related to each other. So they look close, but they are not connected with each other. And this is a thing a RAG cannot solve. So a graph database can solve, and this is a great enhancement for such an agentive system. And in the end, the work result. So from this large context, in the end, so the agent created 100 pages of context, and in the end, the agent compiles a 5-page executive summary and comes back with the answer. Or maybe when you task it, create a bachelor thesis, okay, then the agent will come back with an entire bachelor thesis. Okay, that's it. So with that said, let's go to Robert.
Brilliant. I mean, what can I say? It is exactly as you said, Eckhart. There's a need to upgrade a certain problem that is inherent in what an LLM or what an current state AI does, right? And one of those things, as you've stated, is that life is not only a table, it's not only a bullet list, it is usually a graph, it's usually a network, it's usually something where you have interrelations between things, right? And one of the most important parts in whatever we do is to focus on the digital side of a company. So what Value Miner does is we create digital twins of a company's data and of a company's assets, right? And therefore we use the graph database in order to connect things that are usually from a system point of view not connected, because the financial data is in SAP, the cost centers are there, and then you have projects running around in other systems, and you have patents in brilliant systems that are provided by, for instance, Dennemeyer. And how do they connect? How do they interrelate, right? And usually people do that, and that is tedious work. That is searching, finding, going back again, right? And just imagine if you could have had some agents like the ones that you have just from a technical point of view described so brilliantly, Eckhart. But if they're hallucinating, it's almost like a bad assistant. He creates or she creates even more work than you had before. And therefore, we have taken stuff out of the history books, because I was not only a SED80 user and owner, but I was also, how shall I put it, unfortunate to win a contest when I was 15 to attend summer school at a university in Germany, and that was in 1985. So now you know how old I am. And it is actually true that in those days I felt quite unfortunate, because summer is actually the time where you want to do different things, right? So in those days we created rule-based expert systems, right? And a knowledge graph is a bit like that kind of thing, right? It stores information in that way, right? In a relatable way. So imagine if you can speed up your searches and the quality of your interaction with an AI by utilizing your entire set of data. Yeah, not only what you have vectorized, but everything that is everywhere, because it is there, right? All you actually lack is, or might lack, is access, and is the problem that different data has different data structures. But this is a problem for another day. Oh, could someone get me back, please, one slide, because I was too overly ambitious in moving there. Thank you. So what is a knowledge graph, by the way? It is, as I said, a digital representation of the data itself. It is something that has structural data, structural knowledge, like the relationship that you have within your set of friends or within your family. And there is node data or data that is stored on an object that is utilized. And as you can imagine, there is tons of different objects in your digital twin of your company, right? There's projects, as I said, there is IP, there is patents, there is laws, there is internal compliance, there is financial representation of your assets, and there might even be the odd process to run. And what you can do with a knowledge graph is you can not only take the structure of information out of the data that Eckhart has so brilliantly shown is residing in documents to use them in RAGs, stored in a vector database, for instance, or that Michael has taken out of the IP world as he was able to search patents in a very, very unique way a couple of years ago. And imagine if you can connect those patents, those information to your assets, to your production floor, to your shop floor. It is incredible, right? And we do that on a daily basis. And of course, we have profited from the quality improvement that Eckhart has shown in terms of the LLMs getting better every day. But we also have profited from the realization of the clients that you need to have your information, your knowledge stored so you have access to it, right? Because what you don't want to do is you don't want to integrate your knowledge, your secret IP into an available database on different knowledges. So what you want to do is you want to make sure that the data and the information is safe and that you are in control who is accessing it. So knowledge graphs can be utilized to enhance the quality of the results that you get. So hallucination is less of a problem. And it helps you to tune LLMs or the agent systems to your world. Or as Eckhart put it, it is basically taking the stuff that is in your cellar up into the LLM, right? Or if Gollum would have had a knowledge graph, Bilbo would never have tricked him. So the most important part that I'd like you to remember from this slide is that a digital representation of your company is not an Excel file. It's not a table. It's not a Word document. It is a network of information, and knowledge graphs is what we use to represent that network of information. How do we use that? We use that to enhance the efficiency, the precision, and of course the security. Because if we can select what part of your digital twin or your digital information is utilized within Eckhart's agent systems, may it be through tools, through scripts, through enhancements, it is basically your decision what agent, what part of the LLM world can actually access what part of your internal information. So transparency is no longer in conflict with compliance. Interaction, role-based interaction. For instance, one of our clients uses this in order to facilitate idea generation and idea management. And Michael has mentioned the ability to write patents. One of our clients has found that he has already 3 drafts for a specific idea. And this was made possible due to the knowledge graph structure because it connects different areas. So this all is quite nice, but let's go a bit more into this control over who is accessing what. In a company reality, it is always important to be very much sure that whatever your searching for, whatever you're researching, is your IP. So what we combine is we combine knowledge graphs with role-based access and organizational structures. And what this does is basically what you do. You have an organizational chart, right? And this org chart defines whether marketing is allowed to talk to, I don't know, R&D at all, right? Because it might be on different separate boxes and might not be interlinked. So we copied this and brought it together, for instance, in managing IP-related issues, security issues, in terms of allowing, even in a changing organization, access to certain information parts via the org chart or the organization compliance, as we call it. So what we utilize the knowledge graph for, because an org chart is just a graph, right? Just a tree structure. We utilize that in order to control and facilitate access. And at the end of all this, it is just another form of representing what you do on a daily basis. So here on the left, you see how the data that I just described so florally is actually depicted in our system. It's a graph structure, and we utilize it to talk to our data, right? So therefore, in IP management or in R&D, what you do is you talk to your entire set of knowledge based upon the role that you hold in the organization. So if you ask as a marketing manager, it will give you a context that is suitable for a marketing manager. And if you ask as an R&D manager, it is suitable for your R&D management part. Hence, it is utilizing the power of an LLM that has by now deciphered the basic operation system of humans, and that is what we use right now to communicate, and that is language. And it uses it to help us. So Eckhart's part will be easier. Michi's part will be much more potent because of the ability to combine information. And that would be what I have to say today.
Thank you, Robert. Great presentation.
Perfect, Robert. So you also mentioned a little bit the 80s, right? I grew up a little bit in the 90s, and it was in the 90s when I first got access to private television. And in private television in the 90s, you had commercial breaks. Yeah, the commercial breaks was around 30 seconds back in the 90s. If I now look today into commercial breaks, it's 30 minutes. So I do a little commercial break, but I'm going to do a little from the 90s. So just in the audience bear a little bit with me, because if I don't do this, then my sales and marketing team will go after me in the kitchen. And I really like my coffee. So just 30 minutes for a little bit of a commercial break. On the Dennemeyer side, we have a lot of services in the field of AI, where we also have products. For example, if you have a problem with patent search, patent monitoring, analytic landscaping, then we have a very nice platform, Optimine, in this sense. We also have a very large law firms where we are in worldwide active, of course, specialized also on the drafting, on the filing, on the prosecution, on the whole IP value chain. And of course, we are also organized in practice groups for specialized expertise in certain domains. We then, of course, also have a IP management system Lite. This is our newest one. So this is fully freely available. We have also AI components in there. The only thing what you need to do is you need to upload, or you need to put your name in, then all the patents will be uploaded and also monitored. So this is a very early version now, but we put it live and we're going to continue that route. So simple IP, if you have a small portfolio, check it out. If you have a large portfolio, please come back to us. But then Dimes IQ is the product you look for. And we also will launch on Friday our new custom GPT, so that you can also on ChatGPT in the Explore part, that you can launch a little patent search, and with solid information, solid data, because as the other two gentlemen said, that's the key in order to get a good result out of that one. And yes, Robert, you have invention disclosure statements also in your tool. Therefore, we also have an API together. So that means when you want to access OctiMine out of the value miner system, then this is absolutely possible for all patent searching analytics and all the indicators. And yes, I think it was around 45 seconds or maybe a bit more, but that was the commercial break. And by this one, I think we can now move a little bit to the question session. Good. In this way, I will stop the sharing of the presentations. Now having a couple of questions. Maybe the first one, Eckhart, as you are one of the evangelist pioneers, really knowledgeable experts in the area of AI. But on the other hand, you're also representative of the industry. So first question in this case to you, how do you see RAG and agent-based models transforming manufacturing industry and industry 4.0? And maybe also a little bit, where do you see the main challenges, significant challenges there?
Yeah, thank you. My background is real producing industry, shipping machines to all over the world since 70 years, having old machines. Our machines are at the customer side, sometimes 25 years old. Service documentation and drawings are 25 years old, and knowledge management in a company that has been grown by acquisitions and several data silos with different kinds to label things, different processes merged together. I think this is in Germany for the small and medium-sized companies quite a normal situation, and it was since 1 year not clear what to make out of it. And we are not large enough to just develop new things. So we have to wait until it's clear what the direction is. And now the direction is totally clear. Get the machines with IoT gateways network together, harvest all the data, and there is no chance to get the chaotic data structure from folders that are 25 years old and still necessary, valuable information when the service technician travels there. This 25-year-old documentation is the thing that documents what we shipped 25 years ago. So here Thomas asked a question, how can we make our documents accessible to LLMs? So this is a wrong way to ask the question. Everything that's there is quite amenable to be digitized. And a lot of tools are evolving now, and the quality of the tools is getting better and better and better. So we are a bit on the waiting side because we saw so many problems with tools, and the quality of the digitization was quite poor, and poor data, garbage in, garbage out. So the very, very, very first important step is digitalization. So that we get the data into one accessible data store. And from that on, we currently do not need agents. The agents is not it's just playing around, and this will in the next 2 years will solidify, and we will see where we go to. But today the large language models are so slowly working. We be the agent, and then we have better control what's going on. And when the AI is 10 times faster, then the agents will come out on their own. We do not agents come. That's like the sun is going up. Yeah, so it's a given. So, but the prerequisites to get the data accessible for these modern knowledge management systems. This is the main thing most companies are currently in the process, and we are no different from others there.
There's a very simple solution to that, and that is one thing is to integrate the organizational governance that you already have for the access rights to those documents into the AI system, which we do on a regular basis. Therefore, you have complete control, just as you said. And I totally understand what you said about the quality, because I just come back from a journey to Microsoft and to Meta and to Google, some of our partners, and one of our biggest partners is OpenAI. And what they have in the storage called Strawberry, it's a Q-star model that is exactly going that way. So exactly as you said, and it's not far out. It's not far out.
Okay, perfect. Maybe then we are already entering a little bit almost best practices. So Robert, I mean, you're implementing those RAGs also on a regular base. Can you tell us a little bit more about best practices when implementing those systems, because they get more and more important and we see companies nowadays going into this area. So what are the best practices nowadays?
First of all, don't create a singular data model. Use a graph database, because there you can basically combine the data structure from all the different parts of your company that you can use. Your product management system will have a different data structure than your IP management system, and so on and so forth. And with a graph structure, you basically have that on a node, so you just can combine them as you like. And the best practice is to start at a specific task, for instance, searching for existing patents, searching for existing documentation, helping research or idea creation. And if you do that, you can extend it to assets, extend it, because the brilliant thing about a graph database is you have one node, and if I add another one to my cap, I have 4, right? And if I do that in a table structure, I'm screwed. So
Makes
start
perfectly sense.
start somewhere simple, and then let it grow.
Can fully confirm that. That's also a little bit the experience that we had. When you start simple with a dedicated problem, then it grows, and then it grows very well. But let's also talk a little bit about the cost side, because I mean, accessing large language models, tokens, and you can pay per token, and you have validations back and forth. So looking at RAGs, what are typically setup costs for RAGs, and also the maintenance costs? Can you tell us a little bit more about that in a corporate setting, so that the audience gets also a little bit of feeling on the cost side?
It depends on the scaling, right? Because it's the biggest cost driver, as you said, is the computing power that you actually need. For instance, we at ValueMiner, we start with RAG systems that go for 3,000 a month, and those are good to utilize a couple of at least gigabyte of your data. We have the biggest client who is utilizing terabyte of data. He's going for 30 to 40,000 a month, but that is literally computing power that he pays for.
Okay, good. Then I think we are now almost reaching the end, but question, Eckhart, goes a little bit to you. In one of our other panel sessions on AI in the IP field, we had Dietmar Hahoff speaking, and he was mentioning a little bit, especially SMEs struggled a little bit with the digitization waves in the past. So now, question to you: what can SMEs do in order to really catch up efficiently on the AI wave?
So for the time being, data governance and setting the priorities right, because now it's clear that data is the thing that will guide us to the future. I said 3 years ago, in the future, in a corporation, in a galaxy, at the center of the galaxy is a black hole, and at the center of corporation will be an AI system, and this AI system needs high quality data, real-time data, and interfaces to everything that's going on. So you speak with your ERP system and you ask for reports, and then some API thing goes on in the background, and you have a AI intermediate layer covering your knowledge information system of the corporation. And all these clicking around with graphical user interfaces will be a thing of the past. You will get reports, you get your jobs done, and you have much more automation. This is what's going to happen. And to have the risk low, put data first, data governance, data processes, and what Robert said, that you use existing governance structures and start your journey. As is, it is a complete journey, but now it's absolutely clear where you're heading. And when it's clear where you have to go, then it's clear, okay, you have to take the first steps.
But now, Eckhard, we have answered Michi's question, and I think it's quite unfair in a panel that only he gets to ask. So let's dig a bit into his brain. So, but Michael, you've been on this journey now for what, 10, 15 years, right? Don't want to make you older than you are. But the thing is, what do you think? What is the main application that those LLMs, the current state, is in IP?
Yeah, so I think, first of all, thanks for 15 years, Robert. So I think what we have seen in the IP industry on the application side, I think this was tremendous. Now, I have never seen before that in just 1.5 years, almost all the search tools have picked up on LLMs, have integrated LLM capabilities in their tools, API based. And I think this is really an amazing move in the industry, especially on the search side. We see all the tools going into patent drafting nowadays. Most of them also use LLM technology. So this also happened in the last 2 years. That means when it comes to LLMs, a lot of things are going on. Also on the traditional IP management system side, they more and more integrate LLMs, IP assistants, and so on. And I think this is already a lot that happened. Now coming a little bit to the RAG side, this is where we say in Germany the Luft die Luft wird ein bisschen dünner. Yeah? We are in thin air because there's not too much there. I know that some of the drafting tools, they didn't confirm it, but I have the feeling they also have a RAG in place because this is where they store all their existing patents, invention disclosure statements, so that it can avoid hallucination and those kind of things. I also see those assistants on the IP management part on the rise. So I think this will also get more and more important on the IP management system side. This is also what we see. But what we see quite often these days is that also the medium-sized companies, not only the large ones, create their own LLMs, their own LLM infrastructure, for example, as part of Microsoft Azure, also for data security reasons. Yeah, and this is also what we see in these days. When it comes to agentic systems, then there's a lot, let's say, thinking concept around. I think a true multi-agent based systems has not been in place yet. But I guess, for example, on the searching side, this is what we can expect soon. And searching is also very important for landscaping and all the other things. So I think this is a little bit, when I divide your question in those 3 parts, this is a little bit the state that I currently see.
And let's not forget, because Svein, out of the audience, asked a very, very good question, right? Because if you say they build up their own RAG systems, so basically he's pointing to us and asks, hey guys, what kind of a person should I hire? What kind of a skill set do we need, and so on and so forth. And there's a very interesting answer, and please back me up on that and pitch in, Eckhard. It's basically twofold. One, you need very smart people to understand their subject, because you need experts. I had a very good chat with a friend who is in the US, responsible for the education of younger generations in Washington. He said, hey guys, we just need to train our people to think, right? So that's one thing. From a technical point of view, anybody who is able to set up a server, who is able to set up a system like that is fine to set up a RAG system. That's not really demanding from a technical point of view. The point is the organizational governance, as you said. And another thing that we need to point out is it is not about whether the AI revolution will come. There is already stuff going on, right? So it's just a question. I don't know where this will go. So please, Eckhard.
My take is agile mindset, learning, and doing, and do not love what you did yesterday, because you have to pivot all the time. So this agile landscape will stay forever. So lifelong learning is a thing that things that are half a year old are completely out of use.
And use your data approaches not only failed because of that, because the lifelong learning was not there, but because it was complicated, right? And RAG systems and what we do, knowledge graph, basically lets you just talk to your data as if you would chat with it. That's the complexity of interacting with your entire knowledge set based upon organizational compliance. But hey, Michi, I was rudely taking over.
No,
Sorry.
that's fantastic. I think we almost reached the end a little bit, but maybe my last comment also to that question is that it's great also to have an excellent partner in place that helps you on that from a corporate setting. But on the other hand, we also should not forget you also need to build internal skills. So don't ignore that, because otherwise you will not be able to judge what the partner, the software provider does. And also you need to develop it further in your domain, in your setting, and therefore you need to have technical and domain expertise also a little bit in one team. And I think from a corporate perspective, that's also kind of quite important, I would say.
One thing is lighthouse projects. Yeah, so that to teach the organization, it's valuable to have good teams that make successful lighthouse projects that show to the entire organization that this new way of working, new way of thinking, new way to tackle issues is more productive, better quality, and that people are happier with that approach. So make it a success in your organization, that your organization learns.
And do a Lego approach. Do not build a monolith, but be sure that you're able to switch the engine whilst you're flying, because we don't know where this is going, right? So this is why knowledge graphs, and I'm not pitching this for value minus sake, but get ready just to have your information stored that whatever kind of AI will be in the future, and as Usman has asked, whatever reasoning engine will be in the future, whether it's Q star, Strawberry, whatever, be able to switch it out. And this is why an IP-based structure of microservices is so important as an architecture.
Maybe I can also add quickly to the question of Usman. I think the Jan LeCun paper also helps a little bit in terms of the answer, because you're going to start, let's say, with one, but then if you look at the broader context, having all a little bit in one model, but different parts communicating, going back forth with each other, having an internal model, a little bit of the world, then this is a little bit providing an answer also for that question.
And Usman, don't forget the XSTMs, the LSTMs, or the memory parts of all those systems, because much of our smarts come from remembering or standing on the shoulders of giants who were before us.
Fantastic. And now I think we have to stop, because the team Mondag, I think they're already sitting there getting a little bit excited because we already took 8 minutes overtime. I hope the audience is still there, but I think then now it's time for you to take over for all the questions that we did not answer. We will get back to them, promised.
Absolutely, Michael. And no, it's our pleasure to host you for a little bit extra, a really fascinating discussion today. And we look forward to hopefully having you back at a future date. So Robert, Michael, Eckhart, thank you so much for your insights and your expertise today. And also to our audience, thank you for being with us and for those excellent questions. They will be sent on to the panel, who will be in touch. And please do get in touch with the panel if there's any further information you require. But for now, I wish you all a lovely rest of your day. Thank you again, and goodbye.
See you.
Goodbye.
Thanks a lot. Bye-bye.